Hi, this is Leonardo Calderón. I'm a software engineer. This is the presentation for my project. It's called Q-Dino. This, as Maldonado said, Q-Dino is a quantum version of the classical game of Chrome Dinosaur. So I will start with a little introduction about games. So this is the abstract version of what is a computer game or a video game. We need an interface which the user can control some action of the players and then reach a goal. For example, we have seen some hardware for control video games, such as controllers or keyboard, even in touch. We have seen a lot of games. For example, we can control a character run, jump, or kick some balloon, for example. And then we can see some specific task, such as finish a mission or just survive. And this is my introduction for a game, because one of the most simple games that I can find is Chrome Dinosaur. It is the classical version. I will call at this way, because we have in classical computer right now. So what are the controls for that dinosaur? We have to press space for the dinosaur jump, or the arrow keys for the dinosaur duck. So what is the target about this game? Is to jump the obstacles that are in the way. And another additional goal is to come out with the best high score. So it is the resume of the dinosaur. So what is the approach that I have for that dinosaur? Is we want to control this dinosaur in a different way. For example, we have a set of quantum gates, I don't know, X, C naughts, and Hadamard. It's the very beginning start. So we need just 3 qubits, because what are the number of possible measures that I can in classical? It's 8 possible values if I measure the 3 qubits. So what represent that combination of results or measures are, for example, the dinosaur jump, one space, or 2 space, or 3 space. And also we can dock the dinosaur the same quantity of spaces. So I want to introduce my how are the instructions for play this game. So first, we need to select a gate from this set. We need to add that gate to the quantum circuit. We can drop any of these gates in any of these qubits. Then the program calculates or simulates the circuit in Qiskit. I'm using this framework because it's a powerful simulator. So then I measure the results of all the qubits. And finally, the dinosaur performs the action that the results have. For example, if 1 of 1, the dinosaur have to jump, for example. This code, it's a decision of the game designer, and you can add some actions for the dinosaur in the future. This game should be available in the following months in full stack quantum computation. It's an open source project, and I would like, for example, to share the package, or for example, in the previous talk for beans, it was incredible to insert this kind of game in an arcade, for example, in a Q arcade. So that is my presentation. I will show you some a quick demo of the video game. Can you still see my screen?
Yeah, we can.
Thank you. So the controls are the same from the classical Dino. So we need to select one of the quantum gates, and then move with the key arrows to the respective qubit. So when I press the first key, the movement of the dinosaur starts to keep. The first one is a tutorial. So there are a lot of quantum gates, and the objective of this project is that the user can familiarize with what is the result of apply each gate to the circuit. So if I select an X, I intuitively know that if I put in the qubit 0, the dinosaur will jump. And that is the main point of these kind of video games or educational games, because we want to the user could intuitively says what should be the result of a quantum circuit. So if the user could do that, probably it could be used as a tool for more complex algorithms. For example, with the classical side, we have a NOT gate, for example, and if you have enough experience to know that the NOT gate change the value from 1 to 0, we can use it in a complex circuit and maybe build a new computer. So this is the main purpose of that kind of video games, that show you how the quantum gates are applied on the qubits. So in a future, after playing a lot of games or something like that, you have the skills to figure out how is the rotation value or the result of a rotation after applying a lot of quantum gates. So I will move some gates. The first time that you play, you have a lot of time to put the quantum gates, and finally, with that result, the dinosaur jump, for example. I added those empty space in order to have time, or have enough time to test all the quantum gates. And when the obstacles come to you, you can jump, for example. Or if you crash with some obstacles, you receive a message of game over. So here's my high score, and I will publish that game, and I hope you can enjoy this game and you can beat me. It would be easy for you. Thanks.
Thank you so much for your amazing presentation, for your demo, or your Q-Dino demo. If anyone has any question from Leonardo, you can write it in the chat.
I have a quick question, Leonardo. This is really great games. But how did you implement the Pi game? I mean, do you need to convert it into installer, or like some kind of executable in order to publish it?
Yes, this is my task. I will compress that in an executable for share the video game. So
I see. Yeah, that's actually very. I mean, my previous problem in generating quantum games is this thing. Like when I use this Pi installer, or I actually tried 3 different package to put the Python, to compile Python code in executable, and also always the executable are like 100 megabytes. even for a simpler game. So it's curious. But thank you for sharing this wonderful game. Thank you.
Thank you.
Do you have another questions, Leonardo? What case do you use to play the game?
Okay, here are the all the key up, up key, down, right. For example, for rotations of the C nodes, the X gates you can rotate it, but the C nodes we need to rotate. Key up and key down are for allocate the gates into the circuit. And also when you press the space button or the space bar is for measure the circuit. That is the basic controls that are the same of the classical game of Dinosaur. I don't know if I answered it.
As Leonardo.
Oh, I just want to follow up on that question. So you actually, it seems like you are mapping the qubit result, like the qubit state, into some action list. Is that correct?
Yes, is that correct? I really put the circuit into Qiskit and measure the results. Yes.
So you can support up, for example, if for 3 qubit, you can support up to 8 actions. Is that a correct statement?
Yes, is that correct? I see. We use the inverse part because we need 8 options. We just take 3 qubits. But if we want to do something additional, for example, quantum obstacles that you need to be entangled for past that obstacles, we can without problems add more qubits for that actions.
Yeah, that's interesting. Yeah, I always have struggle between, like, you know, if the game need to be playing in real time, the user need to respond in real time. Sometimes it's hard for them to memorize the list. But on the other hand, if we can use like this such mapping, it can give us much more like possibility, like 8 actions, for example. So yeah, I think it's really nice to see your demonstration here. It's very inspiring. Thank you.
Again, thank you.